In this video, I will discuss how to calculate percentage composition. Sometimes when you have a chemical compound, you may wish to find out the amount of a particular element in the compound. The chemical formula tells us the different types of elements in a compound or molecule, as well as gives us the ratio of the atoms. Let's have a look at an example such as calcium carbonate. In every one calcium carbonate compound, there are one calcium atom, one carbon atom, and 3 oxygen atoms. We will now move on to a question that asks us to calculate the percentage of each of the individual elements in calcium carbonate. The first step when calculating percentage compositions is to calculate the molar mass. The first element is calcium, which has a RAM of 40.1. We add this to the RAM of carbon, which is 12, and then add this to 3 times the RAM of oxygen, which is 16. When we do this calculation, we end up with a molar mass for calcium carbonate being 100.1. The next step is to calculate the individual percentages. Starting with calcium, we take the mass, divide by the molar mass so that we're converting to moles. So here the calculation will be 40.1 divided by 100.1, which we will then multiply by 100 to convert to a percentage, and we end up with 40.1%. Now let's do the calculation for carbon. 12 divided by 100.1 multiplied by 100 will give us 12%. And finally onto oxygen, of which there are 3 atoms in the one calcium carbonate. We multiply this by the RAM of oxygen, which is 16, divide this by 100.1, multiplied by the 100 to convert to a percentage, and we end up with 48%. Now on to question 2. The question asks us to calculate the percentage of nitrogen in the compound caffeine, where the molecular formula of caffeine is C8H10N4O2. As with the previous question, the very first step is to calculate the molar mass of caffeine. Starting with carbon, of which we have 8, multiply this by the RAM of 12, add this to 10 lots of hydrogen, add this to 4 lots of nitrogen that has a RAM of 14, and then add this to our final element, which is oxygen, of which there are 2 and has a RAM of 16. Now when we use our calculator to calculate this, we'll end up with a molar mass of caffeine being 194. Now to work out the percentage of nitrogen, as that is what the question has asked, we take the mass of nitrogen in the compound, which is 56, divide this by the molar mass of the compound, which is 194, and to convert to a percentage, multiply by 100. When we do this calculation, we end up with 28.9, or to 2 significant figures, 29%.